Next, DMA controller. So I think we all know the DMA controller. DMA is nothing but direct memory access. Here you are going to access the memory device, internal memory device of your microprocessor directly without interrupting your microprocessor. Okay. Here the process will be performed by giving the request signal to the DMA controller by the external device which needs to access the internal memory of your microprocessor, and then your DMA controller will give request to the microprocessor to hold the signal. Okay. Yeah, when you are receiving the hold acknowledgement HLDA signal from the microprocessor to the DMA controller, your microprocessor will hold the all bus lines. That is, all the buses, that is data address and control buses will be folded by the microprocessor so that it will DMA controller will access the data either through or from the internal memory of your microprocessor to the external device. Okay, so these are the steps will followed while doing the DMA operation. The IC number for DMA controller is 8257. So here some features are included. That is, here you will have 4 channels which can be used as a 4 input output device. 4 channel, 4 input output device. Okay. And then each channel has 16-bit address and 14-bit counter. So over channel பார்த்தீங்கன்னா 16-bit address 14-bit counter வச்சிருக்கு. ஓகேவா? And then each channel has transfer data up to 64 kilobytes. So over a channel 64 kilobytes can be able to transfer the data. Okay. And then each channel can be programmed independently. Each channel can perform read transfer, write transfer, and verify transfer operation also. Okay. So controlling, reading, writing, everything done by a separate channel. And then it generates more signal to the peripheral device that 128 bytes have been transferred. So more signal will be generated for the peripheral device, that is the external device, up to 128 bytes. It's possible to transfer the data through the peripheral device. Peripheral device is nothing but other external devices. Okay, through the mark signal, which is generated by the DMA controller. It requires a single phase clock. Single phase clock is enough to operate the IC 8257. Its frequency ranges from 250 Hz to 3 MHz. Frequency range in Kursale, that determines the speed of the IC. Okay. It operates in 2 modes. Yes, master mode as well as slave mode. And the mode operates. So this is your architecture or block diagram of 8257. Likewise, all the interface circuit will be having 2 buffers, that is data bus buffer, read write logic. Okay. So data bus buffer la data lines, 8 data lines will be connected. Read write logic la pathina read and write signal for the input output device. Okay, input output rate, input output write. Clock signal, reset signal, this will be acting as a address A0 to A3. Okay, address line and CS for chip select. And then control logic and mode set register. That is, it will control all the blocks by providing the controlling signal. That is ready, HRQ, and it is nothing but whether it is busy or free. That will be done by HR. That is hold request. Okay, hold request is given by the 8257 to the microprocessor. அதனால இப்படி அவுட்புட்ல எரர் இருக்கும். hold acknowledgement இது request acknowledgement. 1 minute phone call வருது. Okay, fine. So control logic and mode set system will control all the blocks, okay, in the architecture by providing the ready signal such as your hold request. So hold request is the hold acknowledgement is given by HLDA. Then memory read, memory write, it எல்லாமே controlling signal. AEN is address enable. ADSPD is address probe. Through the probe, you will provide the address. Ready signal will indicate that your device is ready. Like that, it will be indicated from the microprocessor to the DMA controller. So the remaining address line will be available here. A4 to A7. Okay, 8 address line and the A4 4 lines will be available in the read-type logic. Remaining 4 lines are available in the control logic. And then mark, I told you already, mark signal will be generated by the 8257 to connect with the to connect the peripheral device with the microprocessor for data transfer. For that purpose, you will be using the mark signal. And then right side part in the center will be having internal bus. Okay, so this is the bus for all signals to transfer to the microprocessor as well as to the internal blocks of your 8257. So here you will be having 4 channels. So now feature class 4 channels இருக்கும். So ஒவ்வொரு சேனலும் இண்டிபெண்டா ஆட் பண்ணும். சரியா? So each channel hold 16-bit address as well as 2 control signals. Request and acknowledgement signals for the DMA. Okay, it will be generated by the separate channels. Okay, each and every channel will have separate request and acknowledgement signal. TRQ is request, DACK is acknowledgement signal for the request. Okay. And then priority resolver will decide the priority which channel have to connect with the microprocessor for the accessing purpose, direct accessing purpose will be decided by the priority resolver based on the request given to the DMA controller from the microprocessor. Then 8257, this is pin diagram of 8257. Here the same ஆர்கிடெக்சர்ல என்னென்ன சிக்னல் இருக்கோ அதே தான் இங்கே அரேஞ்ச் பண்ணியிருக்காங்க பட் பின் நம்பர் வில் பி இந்த ஆர்டர். So 40 pin dual in package, each side will be having 40 pins. The signals which are used in the block diagram or architecture will be present in the pin diagram. Okay, so numbers will be given here. That's all. First number, 2, second number, third number, the numbers will come. See the same signal input output side, input output side, memory read, memory write, mark signal, ready, hold acknowledgement, address probe, address enable, hold request, chip select, clock, reset. This is DMA acknowledgement, DMA, that is data acknowledgement 3, data request 2, data request 1, data request 0, ground, then address line A0 to A7. Okay, A0 to A7. Okay, and then D0, data line D0 to E07. So in between that you will be having acknowledgement signal 01 and then power supply mix AC. Okay. So first we will be seeing the request line. DMA request input. Okay. DRQ0 to DRQ3. 4 request input because 4 channels are available in your DMA controller. So 4 request lines are possible for that. So here the fixed priority. When your device is working in the fixed priority, then DRQ0 will be acting as the highest priority. DRQ3 will be acting as the lowest priority. Okay, when your DMA controller is working in the fixed priority mode. Okay, and then acknowledgement. DMA acknowledgement lines are from 0 to 3. 4 acknowledgement lines, 4 request lines and 4 acknowledgement lines. This is the acknowledgement signal given to the peripheral device which is requesting for the service. Okay, இங்க request பண்றது என்ன, DMA க்கு request பண்றது இங்கிறது வெளியில அந்த external device will request the signal, request the DMA controller for the data transfer to the internal memory of microprocessor. Okay, on the request the acknowledgement will be provided by the DMA controller to the external device. Okay, I will ask the request for the direct memory access to the microprocessor. Being the acknowledgement external devices DMA controller. Okay, and then D0 to D07 is nothing but data line which is bidirectional. Okay, here in slave mode, it will carry the command word to 8257 as well as from the 8257 it will carry the status word, command word, status word. இதே 8257 பண்றப்ப command word கொடுக்கும், இதே 8257 இருந்து டிஸ்கிரைப் பண்றப்ப status word அது டிஸ்கிரைப் பண்ணும். Okay, command status or different. command தான் ஆர்டர் பண்ணும், இது பண்ணுன்னு சொல்லி ஆர்டர் பண்றதுக்கு ஒரு டேட்டாவா இருக்கும். இதே ரிசீவ் பண்றப்ப ஸ்டேட்டஸ் அங்க என்ன நடக்குது அப்படிங்கறத ரிசீவ் பண்ணும். எப்போ ஸ்லேவ் மோட்ல. இன் மாஸ்டர் மோட் these lines will be used for sending higher bytes. Okay, address send பண்றதுக்காக இந்த data lines யூஸ் பண்ணுவீங்க. Okay, so address proof signal யூஸ் பண்ணீங்கன்னா, I mean address proof signalல வந்து high signal provide பண்ணா this address will be latched. Latching is nothing but it will be temporarily stored. Okay, then IOR. What is IOR? Input output read. Input output read process. Okay, so input output read வந்து barல இருக்கும். அப்ப இங்க low signal கொடுத்தீங்கன்னா input output device read பண்ணும். எது? CPU. Okay, CPU will read through the DMA controller from the input output device. இது வந்து input output write. Write means you are going to send the data from microprocessor memory to the input output device. Okay, which is externally connected to the microprocessor through the DMA controller. This clock signal, I think you all know, which will provide the clock frequency signal to operate, which will determine the speed of the IC. And then reset signal used for disabling the channel, DMA channel. And then A0 to A3. This is the 4 least significant address line which is used to indicate the address where to write or read in the memory device. Chip select. Okay, chip select will select either we have to operate the read or write operation to the 8257 or from the 8257. Okay, because here we will be using slave mode and master mode. So at the case of it will be selected. Chip select will be selected. A4 to A7 is nothing but 4 higher significant address lines. Okay. Then ready signal will indicate that it is ready to transfer the data between the microprocessor memory with the external device. HRQ is nothing but hold request signal. Okay, request signal provided by the DMA controller to the microprocessor. It is hold order acknowledgement. Okay, HLDA acknowledgement provided by the microprocessor to the DMA controller. Okay, இந்த இது DRQ acknowledgement வந்து external device to the DMA controller. Okay, இது வந்து பாத்தீங்கன்னா hold and HLDA DMA controller with the microprocessor. See the difference? And then memory read, memory write. So memory read and memory write, write and reading process done in the internal memory of your microprocessor. Okay, இது input output read and the input output side பாத்தீங்கன்னா input output device will read the process and the write the process. Okay, writing process and reading process done in input output device itself. ஆனா இது வந்து memory deviceல writing and reading process done. Okay, is an ADST address probe, okay, which will convert the higher byte of your memory device, memory address generated by the DMA controller will be latched by using this signal address probe. Address enable, okay, address enable என்ன பண்ணும், address enable high ஆனா மட்டும்தான் your address bus will be enabled, okay, otherwise it will be disabled. Then TC is terminal count, okay, terminal count means the cycle DMA process will be entered by applying the TC signal, terminal count signal. DMA controller will stop the operation, that is indicated by the TC signal. Mark. Mark is the signal generated by the DMA controller for the data transfer, okay, between the peripheral device to the microprocessor for multiples of times. Here, maximum 128 cycles can be utilized. Then VCC is nothing but power signal, okay, power supply. Okay, maybe plus 5 volt or 8 volt.